Welcome back, everybody, to Lecture 3. Today we're going to be talking about measurement and reliability. So first on our roadmap, today we're going to be talking about how do we measure behavior, what are the different methods we can use, and then what are some types of measurement scales when we are measuring, how do the different kinds of measurement differ from each other. We also want to spend a lot of time talking about how do we know that we're measuring the same thing each time that we do a measurement, and then when we're doing that measurement, how do we know we're measuring what we want to measure, something we talked a little bit about last week as well that we're going to return to. First, as a reminder from week 1, we saw this word empiricism. This is a reminder to you that as researchers, everything we do is using evidence from our senses or from instruments that assist our senses as the basis for our conclusion. So instead of just theorizing about things, we are actually going to collect that evidence. And so talking about measures is how do we collect that evidence? And there's a huge body of research focused on what's known as psychometrics. This is a field of study concerned about how do we measure things, particularly in the psychological and educational fields. So we use this psychometric research and psychometric terms and understanding in order to define our instruments in how we quantify these phenomena that we are observing, these behaviors, these thoughts, these feelings, all of the psychology that we're talking about. And as a field, we are trying to use different instruments together. So not just the same instrument every time to measure the same phenomenon. We like to take it from different angles. Researchers are always trying to use different instruments. And then if you can triangulate, if you can get these converging operations where all of the different instruments and different ways of measuring a phenomenon kind of all come to the same conclusion and support the theory in the same way, then you have a lot of good evidence to support that theory. And we could say we have a good theory. If only a single form of measurement ever really shows the theory is correct, then maybe the theory is not as robust. Maybe we need to find different ways of understanding that theory or that phenomenon such that other instruments can pick up on it. So thinking about the different forms of psychometric measurement, we have basically 3 ways we can measure behavior. Those are through observation, through physiological measures, and through self-report. And we're going to talk about each of these 3. The first form of measurement is through observation. That's any behavior that we can see, we can record. So this could be anything visual, so bar pressing, or how much someone's salivating, kicking or hinting, the number of times, or how many cigarettes are smoked, or how many bottles of beer are drank, or how many buttons are pushed from the elevator, or how many times is it pushed to walk across that street, or how many times does it take to complete a task. These are all just various things that we can see. You might remember that last week we talked about operationalizing aggression. And so we have this aggressive faces that you could do, or how much sriracha was poured in the liquid that was consumed after somebody had bumped into you, or how much do you hold a door, how many times do you hold a door, or how many times do you open a door for someone else, or what's the likelihood of that? These are observable metrics, things that we can see. And so this is part of that operational definition, the specific way a construct will be measured. And remember that this can be done in both person or via any kind of recordings, as long as it is observed. For instance, you have couples arguing and you can take a camera to them from the other room, or children playing in a room, or learning in a classroom, and we can record that. Or maybe we just want to have audio recordings like the ear on your smartphone device to see how much do couples fight. Those are observations because they're something that can be viewed. But we might not be able to view everything. Humans are complex creatures. They have internal processes that we can't have access to. So there's also the physiological measure. These are processes that are not directly observable. We can't actually see them with our own, resources. We need to use instruments. So this might be things like blood pressure and temperature, or external temperature. This could be heart rate, brain activity through EEGs or MRIs. They could be galvanic skin response to see how stressed out are you, how much is your skin tingling. It's a real phenomenon. And these are really cool because the quality of our technology is constantly evolving, constantly getting better. That the way we used to measure physiological are nowhere the same that we do now. We have found different ways to see on deeper levels. And so older studies might not have the best methods of measuring physiological phenomenon as newer studies, and part of these psychometrics and part of being a researcher is finding new and more improved ways of measuring things that are not directly observable. The final method of measuring behavior is through self-report. These are when people just respond and tell you about their thoughts, feelings, and behaviors. And it depends on people having access to their own internal thoughts, feelings, and behaviors, and you asking the right questions to accurately assess their thoughts, feelings, or behaviors. So even more of psychometrics, while the observations is pretty simple. I can count the number of cars I see or the number of times somebody frowns at somebody else. But self-report is a major focus of psychometrics, is figuring out the nuances to how do we ask questions and how do people answer. And these questions, these self-reports are often conducted via questionnaires or interviews. So either having someone fill out something themselves or you are actively asking them questions to delve deeper. And this is a difference between qualitative and quantitative as well in your items. And I want to establish this now so that I can use these terms qualitative and quantitative in the future. So a qualitative variable is any kind of data that has a quality to it that uses maybe categorical labels, so names or descriptions of a phenomenon, but it is not numbers. So it might be, how are you feeling today? And somebody describes in depth how they are feeling. There's not really a number. You can't say, oh, they're feeling a 7. Well, that's not a qualitative. But if you did ascribe a number to it, that would then become a quantitative variable. This is where you describe a specific quantity of the data using those numeric values. So how many times did they frown? How many drops of sriracha did they put in the drink? How happy on a 1 to 7 scale are you? Right? That 1 to 7 scale, on a scale of 1 to 10 or 1 to 5, all of those are quantitative variables. The number might be associated with a qualitative label, with a categorical label, but the number is what's actually being used for any kind of analysis. That is a quantitative variable. Whereas, going back to a qualitative variable, the qualitative can never be converted into numbers effectively. It can never be denoted in that way. So this is usually open-ended responses to different kinds of questions, something we'll talk about when we get to talking about how to construct surveys. So again, these are terms I'm going to be using later on, similar to categorical and continuous variable. I also want you to keep in the back of your mind these terms qualitative and quantitative. So speaking of self-report, here is a self-report happiness scale. This is the subjective happiness scale by Sonia Lyubomirsky. It has 4 questions in it. So take a moment to pause. You can write down on a sheet of paper your answers on this. Again, each question is on a 1 to 7. Look at what the different anchors, those endpoints, a 1 in the first question is not very happy, a 7 is a very happy. So read those anchors and respond to this. All right, so you've just finished that subjective happiness scale. We'll get back to that a little bit later, but now we're going to talk about measurement scales. Specifically, how do we distinguish between the values and the types of values that a scale can have? As we talked about last week, every research project, every variable starts with a construct, and we have to define that construct. And so that's a conceptual definition. What is this construct? What does it mean? So let's think about happiness, the scale you just filled out. What is happiness? How do we differentiate happiness from other similar constructs such as joy or calmness or sense of satisfaction? What is happiness? And once we have a conceptual definition of happiness, we can then move on to an operational definition. This is, how do we measure that construct based on how we understand that construct? How are we actually going to turn it into a scale, a measurement that we can use? And as we just said, there's possible different operations. You can have an observational measure, such as how often does the person smile? How often do they hug other people? How often do they act in ways that look relaxed? We could do physiological assessments. So maybe relaxation is kind of a hard thing to view, but we can assess it. Maybe we can measure serotonin in the body, or we can measure endorphins for this happy feeling. Or if we don't think that those measures are quite what we want, then we can do a self-report measure. So we could ask a simple question of how happy are you? And we could do that as an open-ended qualitative question where somebody just describes how happy they are and they use their own terms and there's no real numbers associated. Or we could do a quantitative version where we ask how happy are you? And maybe they say on a 1 to 7 scale, I'm feeling really happy or I'm not feeling happy at all. We could also go one step further with a multi-item scale where we can kind of triangulate through different ways of asking about happiness, like you just filled out. It had 4 different ways of looking at happiness and assessing them. Some maybe felt better than others, but all of them are kind of triangulating this idea of happiness and trying to measure it in different ways. And once we have that data, or once we come up with a different kind of operational definition, we then want to create our scale. And we have 4 different values, 4 different value systems, scale systems that we can use to measure these variables. So the first is what's known as a nominal scale. So going back to that single item, how happy are you, or are you happy? A nominal scale is just a categorical answer. So in this case, it might be yes or no. Or here we have the middle school example. Do you like me? Mark yes, no, or maybe. So in a nominal scale, categories are qualitative, right? There's a quality to the value. It means something, but the number is just a label. So different numbers mean different things. A 1 might be attributed to that yes, or 2 is attributed to that no. We can apply these values, these numbers as labels, but the order doesn't matter at all with a nominal scale. The name is the only thing that's applied, and what order they're applied, what number is associated. We could do that no equals -99 and yes equals 1,302. It doesn't matter because the values don't really mean anything. They're just kind of indicator. They're labels, but the actual answer is what matters. So order doesn't matter, but different numbers do mean different answers. And this is good for categories, but it doesn't allow for very many statistical tests. Because there's no quantitative value, the value of the number doesn't really matter. We can't really do any calculation. We can't get means or standard deviations. We can't calculate the average of yes, no. What does a 1.5 on a are you happy yes, no mean? What does a 1.1 mean? It doesn't mean anything, so we can't use those averages. This is the same thing with most nominal scales. We just can't convert them into any usable numbers. The numbers are just labels. Now, a nominal scale doesn't allow for any kind of order. Again, a yes, no could be in any order. It could be no, yes, it doesn't matter. But some variables we do want to have order. So as an example, let's think about attractiveness. I'm going to give you 3 example individuals, and you think about how you would rank their attractiveness. So first we have Danny DeVito. And so you might think, oh, where do I put him? Maybe he's not on the highest attractiveness scale there, but we don't really have a context. We need a comparison group. So let's give you your second indicator. How about Steve Buscemi? All right. So you might be having a little bit of trouble here evaluating, where do they fit on this attractiveness scale? And what's going to be the third one that Professor Julie is going to throw at us? And so I'm going to give you Timothée Chalamet. Right, so you can take a second to think about how you would rank these attractiveness. So here's mine, and maybe you have some disagreement. I'm going to go ahead and put Timothy at the top. And then let's say Danny DeVito in the center and Steve Buscemi at the bottom. But, I'm kind of struggling with this second and third one because maybe Steve's a little bit more attractive in some ways than Danny. But I definitely know that Timothy is a lot more attractive here. And that's going to be an ordinal variable because we have some order here. But there's a very important aspect of that order. Let's give another example. So the happiest country in the world. Let's say we have Denmark, the USA, and Canada. So people have actually assessed these 3 countries on their happiness, and we find that Denmark is one of the happiest. Canada and USA are less happy than Denmark, but they're still pretty close. So we have a ranking. They have values of happiness and how happy they are in some kind of order of most to least happy, most attractive to least attractive. That Timothy was much more attractive than the other two. And so we know that different numbers mean different things. We have our first, second, third, our small, medium, large. And the order matters, but what's important here, and what I want to pick up from that attractiveness one, is that the intervals between them we don't necessarily know. We know that Timothy is more attractive than Danny and Steve, but how much more attractive? And Danny and Steve, they're different attractiveness, but how and how much? Is it the gap between Timothy and Danny is probably not the same gap that's between Danny and Steve in terms of attractiveness. The gap in happiness between Denmark and Canada might not be the same gap in happiness as between Canada and USA. You think about runners who you have a first place, and then maybe there's somebody close behind who's getting second place, but then the third place might be a few seconds even further behind, and fourth place might be a lot longer. The interval between them, the space between their scores, is unknown when you have an ordinal scale. And so this means we have very few statistical tests we can still run. While the values actually mean something, first, second, and third, we can't do means for them. We can't average them because the actual intervals don't mean as much. Now we can calculate a median. We can kind of find where on these scores is a middle point. We can get a mode. But we cannot use it for much more because of that interval issue. So if we do want our intervals, then we need to move on to, you guessed it, an interval scale. So an interval scale is any time when there are ordered categories, so we're taking that ordinal variable and we're kind of increasing the level of specificity here. So it has ordered categories, but they have an equal distance between the options. So it is not an unknown interval. It is very specific. So the different numbers mean different things. We have order matters, but they have equal interval between numbers. We know that a difference between 85% and 75% is the same as an 85% to 95%. I have the indicator or the example here of how do you feel today? Very unhappy, unhappy, okay, happy, very happy. And the idea being that between these levels of this scale, between very happy and happy, number 4 and 5, that should be the same kind of interval of happiness, quote unquote, as between very unhappy and unhappy. And this is what's known as a semantic scale, where it's suggested that the difference between these two levels is about the same. Same thing with satisfaction. The difference between somewhat unsatisfied and neutral, so that 2 and 3, should be about the same as between neutral and somewhat satisfied. The interval is consistent. It is not unknown. And when we have a consistent interval between numbers, then we can do more statistics. Once we can kind of use those numbers, and we know those numbers represent some kind of association with each other, that increases from one number to another should be the same as a third variable to the fourth. When there's these consistent intervals, we can do stuff like a mean, median, mode, and start getting into those measures of dispersion like standard deviation. So we think we could stop here with, okay, this is a scale. This is what we're used to seeing, where the different numbers mean different things, and it kind of, each step up means the same thing as another step up to the next level. But there's one piece of information missing from an interval, and that's the 0. So in this interval scale you're looking at, what would a 0 mean? What is 0 happiness? It doesn't actually really mean anything. Or what is 0 satisfied? It's kind of a hard construct to wrap your head around, of just an absence of something. And so interval scales don't have an absence variable. There's no meaningful 0. If you have a meaningful 0 in a scale, then you have what's called a ratio. So this could be a frequency. So how many times did you smile today as happiness? So we have different kinds of smiles. Our Duchenne smile, where it gets all the way to your eyes and you really know someone's happy, versus the fake photographic non-Duchenne. You see people smiling in pictures and you can tell that they're not really happy in that picture. That's that non-Duchenne. So maybe we could measure that. And we could say, oh, they have 1 versus 2, and somebody who has 1 is 1 less than 2, or somebody who has 3 is 1 less than 4, and so we have that interval. But what does 0 mean? Well, 0 smiles means something. It is an absence of smiles. The person did not smile at all. So in a ratio scale, we have this ordered categories where the numbers mean different things. There's equal intervals between the numbers, but 0 matters. Once 0 matters, we can now make ratios. We can make these comparisons that something is twice as much as another, or 3 times, or half. We can start to manipulate those numbers in a lot and interpret that manipulation in new ways. All right, so as a review, oh, and by the way, this allows for more statistics. So again, that multiplication and division. So here as our refresher, our summary of the different scales of measurement, the nominal is when there's just names. There's nothing else. It's just a category. The ordinal, we add one step more where the order matters. Interval, we're saying order matters, but also the space between those orders matters, those intervals. And then ratio is when we have all of the order, we have all of the intervals consistent, but there is a true 0, so we can create ratios out of them. Is 2 to 1, 3 to 1, so that's when multiplication and division comes in. So how you can remember it, nominal is Latin for name, so name is the only thing that matters. Ordinal, there's an order that matters. Interval, the intervals between the different levels matter. And ratio, because there's a 0, we can create ratios out of the numbers. We can do multiplication and division comparisons. All right, so now that you've seen all 4 of them, let's do a type of practice with you. I have 4 examples here. We have temperature, military rank, gender, and how much money you have. So let's see if you can take a minute, pause, and try to figure out which type of measurement they are. Okay, we're back. You've unpaused. So let's talk about temperature. Do the categories of temperature mean something, or is it at least a nominal variable? And we can say yes, a 40 degrees means something, 50 degrees means something. So we check off nominal. What about ordinal? Is there a meaningful order to the temperature values? And certainly, as you increase in temperature, it gets hotter. As you decrease in temperature, it gets colder. What about interval? Is the gap between 2 temperature values the same no matter which temperature values you're kind of comparing? So between a 30 degrees and 32 degrees, is that 2 gap the same as between a 40 and a 42, or a 46 and a 48, or a 98 and 100? Yes, a 2 gap kind of always means the same. A 3 gap always means the same. That interval is consistent. So we can check off interval. So the last one we need to see is there a 0? Does 0 degrees mean something? Does it actually represent? Now, there can be a 0, but does it have some absence behind it? Does it mean something very important to the phenomenon, to the construct? And when it comes to Fahrenheit and Celsius, that's not true. 0 is just another number when it comes to temperature. It's just more cold. But there's no absence of temperature. True 0 doesn't mean anything. And I specify here Fahrenheit and Celsius because there is a version of temperature that does have a true 0. It's called Kelvin, where 0 is complete absence of any molecular movement. So it means something. But for us, we can't ascribe a true 0, so we can't go ratio. We are left at interval. All right. Hopefully that made sense. Now let's move on to military rank. Do the different categories mean something in military rank? Yeah, of course. So it's nominal. Does the order of the ranks matter? Is there a higher rank and a lower rank? Yes, there is. So we can check off ordinal. Well, what about interval? Is there an equal distance between each rank that is clearly defined? And because these ranks are about responsibility and there's lots of different paths to the different ranks, we kind of lose the thread on that one. It's probably not an interval. In fact, we know it's not interval. So we can just stop there and we can describe this an ordinal style measure. All right, gender. Do the different categories have names? Does it mean something to be male, female, trans, non-binary? Yes, those mean something. Okay, well, is there an order to it? Is there a meaningful ranking of these different genders? No, you definitely lost me on that one. So this, we're just going to stay at nominal. And now finally, the money, money, money. Do the different values mean something? Yes, they do. You can have $10 or $20 or $1,000,000. Does the order matter? Is there some kind of meaningful amounts, more money or less money? Yeah, of course. What about interval? Is the gap between $10 and $20 the same as $1,010 and $1,020? Yes. So now we come to that ratio. Is there a true zero? Does having zero money mean something? Is an absence of money possible? And yes, you can have zero money. So you can do ratios with it. You could say I have twice as much money as someone else, or I have half as much money as my other friend. Okay? So we do have ratio there. So practice this with yourself. When you are walking around seeing different kinds of values out there and different measurements, think to yourself, is that nominal, ordinal, interval, ratio, and what can I do with that information? Speaking of examples of measurements, here's just a few. So nominal, again, these labels are categories. Here's some gender, ethnicity, zodiac sign, no order there. The religion that you are, sports jersey numbers. Yes, maybe they're associated with different positions, but there's no order to it. The rank doesn't matter. Political party, no matter what your ideological views, there's no order there. But when we do have ordinal, we get those military rank, education level, whether it's high school, college, post-college. We have contest results, first place, second place, social class. The order matters. There's a rank, but we don't necessarily know the spacing between them in terms of value. Interval, we have the temperature we talked about, sea level, the year it is, your IQ level, SAT scores, GPA. These are all things that there is a specific interval between different scores, but there's no real zero score. There's no zero IQ or year zero. It just kind of keeps going below and keeps going above. The zero, we can't ratio. We can't say that 2000 is twice as many years as the year 1000 because we're using this arbitrary kind of zero start in that interval. But when we get to ratio, we have things like test score. There is such a thing as a zero on a test, or zero money, or no height. You're just zero. So we can say somebody's twice as high as somebody else, or weighs twice as much, or we ran twice the distance, or we are twice as old. These ratios, these comparisons where we're using multiplication and division, that's going to be a ratio. All right, now we're going to quick transition into a new topic, and this is after we have our measurement. How do we know that we are consistently measuring the same thing? And this is going to be a concept of reliability. So let's have this hypothetical situation where you have a scale in your bathroom, and when you go to stand on that scale to weigh yourself at 10 a.m. in the morning, it tells you maybe 160. But then when you go in at 11, it says 175, and at 12 it says 150, at 1 it says 170. Would you trust this scale giving you different measurements, or do you kind of expect the same thing? How would we know if our scale is broken? You might assume this scale is messed up. It's not measuring weight like I think it is. It must be measuring something else, or maybe it's just broken. So how do we know if our measure is good? How do we look at a measurement, or whether it's a scale or like a physical scale, or it is a scale, some psychometric scale we're using? How do we know if it's good? Classical test theory would tell us that there is a big T truth value for each of our measurements. So when we step on the scale, we weigh a certain amount, and we should expect that that weight scale is going to accurately give us that information. So there is a big T truth, but the weight scale that we are stepping on at 10 and 11 and 12 gives us an observed value, and that's going to be X. So I'm going to have X and T, the observed versus the true. The true score is that actual value in the real world that we hope our measurement will pick up, but it may not. So this is when there is no error in how we are measuring something, and our scale is not broken, then we are getting our true score. But the observed score is whatever we get from our measurement tool. Sometimes that observed score is going to be completely accurate and is going to match our true score if there's no error. But if there is any form of error, then we are going to be different from our true score. So at 10 a.m., you might be close to t, but then at 11 it gives you a different number. That would suggest that the observed score is now not so consistent with the true. Which one is the true score? So we have to take this error into account. We have our observed is always going to equal the truth plus some error. So error is also the truth minus the observed, or the observed minus the truth. This error could be an under or an overestimate. The problem is we don't know. We just know that if our x is not equal to our t, there is some error. Let's have another example of this. So let's say I have an IQ test for a participant. Maybe their true intelligence, if they were to take this with no error, if this was a perfect measurement, their intelligence score would be a 125. But when I give them the intelligence score, they score a 112. So there is some difference between the true and the observed. And so the error is going to be 13, right? It's a negative 13, that this error is lower than what we would expect. This observed is lower than what we would expect in a true situation. And this error, it could come from internal or external factors. So it could be that the participant is sick or depressed or stressed out that day, so they aren't able to fully manifest their intelligence on whatever measure I'm using. Maybe it's the room is too cold, or the test is poorly designed, so it's not quite getting at it, and the situational factors are coming in, so unable to focus on taking the intelligence score and truly meeting that truth, and instead we get the observed. Or maybe they did answer the questions, the intelligence scoring correctly, but the way the experimenter administered or scored after the fact maybe incorrectly gave negative points, so that there was error there. So it could come from the experimenter themselves. So again, it could be the participant, it could be the measurement tool, it could be the situation, or it could be the administrator. There's lots of different reasons. We think of this error in two types, two sources. They could have systematic error or random error. So we've seen that systematic term before. We talked about variation, and there's systematic variation of the IV, the independent variable, is systematically affecting the variation in the dependent variable. Well, here we have the same kind of thing, but in error form. So systematic error is when the mistakes and the kind of inconsistency between the true and the observed is consistently happening across all observations. There could be a number of different factors. So for example, you might have that socioeconomic status is influencing self-esteem in some systematic way, but we're not measuring it. There could be this external thing. It could be that a specific grocer weighs vegetables with thumbs on the scale versus others. There's something consistent that this grocer is always doing that with the vegetables, or that everybody generally wants to appear non-prejudiced, and so they're going to answer in ways that are systematically raising their prejudice value. So there's a system where we know that certain groups, or an entire population even, is consistently wrong or consistently not matching the truth. The observations we're getting are consistently, depending on the group, incorrect. There is that error. But if there's random error, then this is when just some observations are not close to the truth and some are closer. Some have more error and some have less, but we can't figure out why. For instance, some participants might be just in a mood that day. Sometimes the room is cold and sometimes it's warm. Sometimes people misread a question or aren't feeling well, or sometimes the researcher might mistype something, but they're not always mistyping the same question the same way. The participants aren't always misreading the question in the same way. So it is random now. It applies to some participants and some situations, but not others. Whereas the systematic error, it applies to everybody in a group kind of systematically, kind of universally. And systematic can apply to individual groups, and so that's where we're looking for these confounds and these other the internal validity, where one group is having some kind of systematic error versus another, but there is some kind of a known reason why the observations are not matching truth. And what I should say, it's not necessarily known, it's not that we really know what's going on, but it is consistent if we were able to overanalyze it. But random error, we can't know. It's just people are different, things happen. So this is when we talk about reliability. When there is error, whether it's systematic or random, this error reduces our reliability. Whether it's that your scale is always adding 20 pounds to your measurement, or if it's just kind of colder and so it's measuring higher weight, and when it's warmer it's measuring less, or depending on the time of day it might integrate that into its reading. That's whether it's systematic or random, at the end of the day, it's decreasing the reliability. What is reliability? It is the consistency or repeatability of a measure or observation. If we step on that scale, we expect that each time we step on that scale, we should be getting the same answer. And if we aren't, then something's wrong. When we assess somebody on a variable, we expect that if we ask them again, they would say the same thing. We would get the similar results. So here I have this picture of the arrows being shot, and you have the center bullseye where every time it's fired, it is reliably hitting that center. Whereas in the right example, it's kind of all over the place. And we estimate this reliability by having 2 or more measurements of the same thing and seeing if the scores are the same. Again, if we measure it multiple times, do we get the same result? Now, before I go a little bit further, we're going to have another little math break here. This is our quick correlation refresher. So remembering from statistics, what is a correlation? Correlation is a measure between 2 variables trying to figure out what is the strength and direction of the association between them. How are they related? And we use these correlations as a way of measuring reliability. So if you remember, there is 2 aspects to a correlation. Again, the strength and the direction. The strength is on a 0 to 1 to -1, or I should say a -1 to +1, with 0 being the middle. So if we have a negative relationship, it's showing that the relationship as one increases, the other decreases. With a positive relationship, it's as one increases, the other increases as well. And that's where that positive and negative comes in. That's the direction. A 0 means that as one changes, we have no idea what happens to the other. There's no relationship between them. So the examples I have on the screen here, a negative relationship. As the auto value increases, the auto mileage decreases. Or another way of saying it, because you can switch it, is as the auto mileage increases, as you drive it more, the value of the vehicle decreases. So that's a negative relationship. They are related. Mileage changes and the value are related. It's just in a negative direction. Whereas if you have the quality of a car and its color, well, that doesn't really matter. Whether it's red or silver or black doesn't really change how good of a car it is. But then we have an auto insurance cost versus auto accidents. As your number of accidents increase, so does the cost of insurance on that automobile. These are related. The insurance company thinks that you're kind of a reckless driver. They're going to charge you more so that they, can reap their benefits. Okay, so these are correlations, and we don't have to get into how these are calculated numerically at this point, but you do have to understand what you're seeing with this negative, positive, or 0. Okay, so back to terminology and reliability. We want to be getting similar scores across different iterations of using our measure. So we want it to be consistent in different ways, and we have 3 real ways we can assess this reliability. They are through the observer, through the number of times we assess, and through the different items. So the first, the observers, this is called inter-rater reliability. We want consistency between evaluators, that when they score you in one way, another person using the same measure would score you similarly. We also have time. This is called the test-retest reliability. Where assessing an individual at one time point, they should be relatively consistent in the future. And then the number of items, that if I ask a question of the participant that assesses them on a certain construct, and I ask them a similar question that should also assess the same construct, the answers to both of those items should be consistent, should both indicate higher in that construct or lower in that construct in the same way. But let's get into these with some examples. So inter-rater reliability, again, this is consistent across the observers. It's about the raters, the evaluators, those observers. And this can be mostly used with observational measures, noting that the people who are marking how many times someone smiles, or how many drops of sriracha are put in, or what your grading and exam score, these should be consistent no matter who the rater is. So we assess this by asking multiple people to rate the individual, the participant, on the measure of interest. For instance, let's go back to talking about observed happiness. When we see this person here, all of us watching this video would come up with a number or a ranking for how happy does this person appear. And the idea being that if we see this individual and all of us say, oh yeah, this person seems pretty happy, that's pretty high inter-rater reliability. If there's some of us who say, oh no, absolutely looks depressed in this picture, that would be low inter-rater reliability. The hope is that this observable behavior, arms flung back, smiling into the sky, we would all kind of agree with. And the same thing if we saw this picture, we could all ask ourselves, how depressed does this individual appear? And we would probably have pretty high inter-rater reliability when it comes to this observed happiness. So we want consistency between the observers. And if there isn't, if there's some kind of difference between the evaluations, that's going to be error. And maybe it's that some evaluators see things in a different way, in a systematic way, that they always view somebody as less happy in certain situations. Well, that could be systematic and we can measure it. But it might also be that a rater is just feeling unhappy themselves, and so everything that they see looks sad, or maybe they're just filled with joy, and so no matter what they see happiness and joy in what they're rating. And that could be random error because it's just applying to that individual. If it's reliable, then it doesn't have so much of that systematic and random error. So we need to represent this reliability, though, with numbers. How inter-rated reliably are these observations? And that's where we're going to go back to these correlations. So first, we have some examples. Here is observer 1 on the x-axis, and they are evaluating the participant on a certain level of happiness. Some they have pretty low at 2, some they have pretty high at 6, 6.5. And we want to see how related are their observations to observer 2. And observer 2 we also see has some low and some high. And it just so happens that each participant, each blue dot, when observer 1 rates them high on happiness, so does observer 2. When observer 1 said a 6 on happiness, observer 2 also said 6 on happiness. And when observer 1 said 3 on happiness, observer 2 also said 3 on happiness. And it isn't perfect here. There's sometimes when it's slightly off. For instance, observer 1 had that 6.5 for happiness, and observer 2 only put a 5.5. But that's still pretty high. Those are at the higher end of our construct and at the higher end of our measurement. So it's consistent, and lower scores are usually associated with lower scores. So we see that this has a pretty good reliability there. So we might do our math here, and if we ran this in SPSS with all of these data points, you would see that this has an R of 0.93. R is the indicator of a correlational value. And we remember that it goes from a -1 to a 1, with 0 being absolutely no relationship. So a 0.93 is actually very highly related to each other. So we have really good inter-rater reliability between rater 1 and rater 2. Great. We'd like to see that for all raters. But let's say we have another example here where observer 1 is still scoring everybody, but observer 2 is not really matching as much. It's kind of all over the place. Here we would get an R of maybe a 0.03, and that's very close to 0. So here we would say this is unreliable. There is not any inter-rater reliability between these. That how observer 1 is viewing the audience and viewing the participant has nothing to do with how observer 3. There's a lot of error here, a lot of different ways of evaluating the participant. It's not a very reliable measure. But let's have a different measure, and this time we have observer 1 and observer 4. And here we see kind of the opposite of the first situation, where as observer 1 says that person looks really happy, observer 4 is actually saying that person looks very unhappy. So observer 1's 6.5 is actually associated with observer 4's, ranking them as a 1. And observer 1's 0.5 is the same as observer 4's 6 up in the top left corner there. So here we're seeing a negative slope, and we can see that this is R of negative 0.9, close to that -1 correlation. So we call this highly unreliable between rater 1 and rater 4, that as one increases, the other doesn't increase. It's not that because it's negative, it's reliable, but negatively reliable. It's unreliable because we want every time one observer says they're high on a construct, the other observers should agree. So here it is unreliable as well. So only with inter-rater reliability, only when you have a high positive correlation do we think of it as high inter-rater reliability. Our next assessment of reliability is this test-retest. This is our time factor. And this is where we want to see that the individual who takes a survey or a question or a measure at one time point will be consistent with that score at a different time point, so that all the measures they're doing should be stable. And this can be with self-report, observational, physiological, that the person is responding to the measure in the same way, whether it was at time 1 or time 2. So what we do is we measure them more than once on a variable and we calculate the correlation between them. So for instance, we might have trait level happiness and we see, is the person happy now? Will they also be happy in the future? If the person's shining in front of the sunlight now, are we going to see that same level of happiness in the future? And as a note, trait level means just kind of your disposition, your internal. It's not situational. It's just how happy of a person are you? Versus this other individual, again, we have our depressed individual in this picture. If this person is depressed now, will they be equally depressed in the future based on our observation or based on how we're getting the reports? So we find this consistency. And before I want to go on, though, I do want to mention something about this time, that a big caveat in it is the life events. So we are assuming that the time is stable, that nothing major is happening that could influence an outcome between time 1 and time 2. Like if somebody is very happy at time 1 and then at time 2 they're very unhappy, we might want to look at what kind of events are occurring. So time 1 they're happy and then they get evicted, or they have a falling out with a best friend or loved one, or they have a really stressful exam that just really dashes their dreams of a certain career. Then we might see something happening on the other end where there's not so much consistency, and that's going to be that error that we're looking at. But we generally want to see that the person is scoring the same each time. So assessing it in a correlation, here again is a graph. We see time 1, time 2. We have this same kind of chart with the low scores at time 1 are the same as time 2. The high scores at time 1 are the same as high scores at time 2, or similar. Again, that 0.93, I'm using the same data. You see this is highly reliable between times 1 and 2. We have good test-retest reliability. Again, our 0 example, time 1 is have different amounts of happiness, and time 3 it just doesn't match in any way. We have that negative 0.03, again unreliable between these times. And our negative between time 1 and 4, here we again say that it is unreliable, that as time 1, if they had higher scores at time 1, we need to see that they have higher scores at time 2. If they don't, then it is unreliable. Not just negatively reliable, but unreliable. All right, so now we can go back to that subjective happiness scale. Remember this 4-point scale I had you pause on? You were asking yourself if you consider yourself a happy person, how are you compared to others in terms of happiness? Some people are generally happy. How much does this describe you? And then some people are generally not very happy. How does this describe you? And I wanted you to take this so you could kind of get happiness in your mind, but also so you could see what's called a multi-item scale. I mentioned that when we are developing measures, we don't always just want to have one question. We want to have multiple questions to triangulate and get at a better idea of what we're measuring. Because maybe one wording of a question isn't perfect. We want to get at it from slightly nuanced angles so we can really comprehensively operationalize and measure that construct. So here we have 4 different items. And that takes us to our third assessment of reliability, which is our internal reliability, our item level reliability. And this is where we want to see there's consistency across the scale items. You have a survey, you have different questions. You want that as somebody scores higher on one metric or one item that is measuring your construct, they are also scoring high on other items that should measure your construct, that same construct. So in this scale, we have these 4 different items. And we expect that if you said, I am a very happy person on that first question, then you would also rate highly on I am more happy than my peers and I am generally a happy person. That higher on one should be higher on others. But you guys also took this and saw that there was that generally not very happy. And so if somebody said, I am a very happy person, and then also later said, I am not very happy, this describes, not very happy describes me a great deal, well, that's not very consistent. So in fact, here we expect a low rate, or a low rating. So if high on the first one, we expect 2 to be high, and then that last 4th one to be low. So when we are looking at our correlations, here again we have question 1 and question 2 related. If you are scoring high on an item that is measuring your construct, you should be scoring high on the other item that is measuring that construct. This is highly reliable across items. High internal reliability. This other one, question 3 related to it, well, this is not associated with subjective happiness, this is just an example, but if there was a question 3 that was just kind of arbitrarily related to question 1, it was all over the place, here we see unreliable again, close to that 0 correlation. And finally, we have our negative relationship here with question 1, if you are higher on that question construct, then you are negative, you are lower on the other questions construct. And here we have a difference between the other 2 types of reliability, where this one means it is reliable, it's just negatively valenced, that if somebody is scoring high on this one, we can expect that they will score lower on the other. There is reliability because we know that it's not error, it's the way the questions are worded. Now, a correlation is just between 2 variables. It's always just 2 variables for the correlation. You want to add more, you start getting into regressions. But 2 variables is great, but when you have a survey that has more than 2, you still want to see these kind of correlations in this inter-rater reliability, but you can only do the different pairs of correlations with each other. So how do we find how all of the items, how do we find how all 4 items are related to each other? And this is assessed with what's called a Cronbach's alpha. So the first part you do in a Cronbach's alpha is you compute all of the different pairwise comparisons. That's each set of 2. How are they related to each other? So question number 1 related to question 2, and then question 1 related to question 3, and then question 1 related to question 4, and then question 2 related to 3, and 2 related to 4, and then 3 related to 4. All of the different pairs of items, you want to get a correlation. So then again, 1 to 2, 1 to 3, 2 to 3, etc. Then you take the average of those correlations, you do some fancy math with those averages divided by the number of items, you kind of weight them in different ways, and that's when you get your Cronbach's alpha. And we want that number to be greater than 0.7 if the scale has internal reliability, if the different items match with each other. If we have less than 0.7, we know that some of the items, and we have to do more investigation to find out which ones, but we know some of the items don't necessarily flow, aren't measuring the construct in the way that we can. Just so you have some context, the subjective happiness scale that you took there, all of the items hang together at about a 0.79 to a 0.94, depending on when they're taken and which populations. So there is still some error there. Some people are responding to certain questions a little bit higher than others, but in general, it's a really high consistency between them. And I bring up this Kernbox alpha talking about inter-item reliability because we often have more than one item in our scale. But the same can be done with different times and different raters. If you have a lot of different raters all evaluating a participant on the same measurement, you could do a Kernbox alpha using the correlations between each rater. If you have a lot of different time points when you're assessing someone, some kind of longitudinal study over time, then you want to find the correlation between scores at each time point, and you want to find all of the pairs so you could get a Kernbox alpha for reliability there as well. And using Kernbox alpha is a very useful tool in statistics, not just for reliability, but for understanding your measures. All right, so as a review, reliability again, we're trying to take this measurement error into account. The more measurement error we have means less reliability. So the reliability is this consistency. We hope to see consistency. My question to you is, what happens if we're consistently wrong? Okay, so here, we're shooting all those arrows, we're hitting the board, but not where we want them to hit. And that's when we're going to get into our final topic of today, which is construct validity. Construct validity is how do we know we're measuring the thing we want to measure. Now let's start with some term reviews. So we've already gone over reliability, this consistency or repeatability, the idea that if we measure something again, we'll get the same result, whether it's through the same people who are rating, whether it's across different times, or whether it's different items in the same measurement tool that we're using. We also last week learned the term validity. This is the accuracy of a measurement. How much does it reflect what I want it to or capture what the real world looks like? And so we have these different ways of hitting the dartboard that incorporate reliability and validity. You have that first instance, which I showed on the slide just a second ago, the reliable but not valid. We are consistently getting the same answer, but that answer isn't accurate. Versus the middle picture, this is kind of our ideal situation where it is both reliable and valid. We are consistently measuring what we want to measure right there in the center in the bullseye. And then the third option is that we have low reliability, we're inconsistent, and we are not valid. We're not accurate. And an important note here is that there's no such thing as unreliable and valid. Because if you are not hitting the same thing every time, then that means all of the times you're not hitting what you want, you're not measuring what you want either. So you might hit the bullseye once, but if the other times you shoot you're not hitting a bullseye, you're unreliable, well then each of those misses of the bullseye is not valid. So you can't be valid if you are unreliable. Also, a terminology reminder, last week, here's the slide for construct validity. This is how the type of validity with how well did a researcher operationalize, how much is it representing the real construct. And so when we're talking about reliability and validity and that match between them and is it measuring what we think it is, what we're really talking about is trying to balance construct validity. Are we operationalizing, are we creating a measure of our variable that accurately reflects it, that is measuring the real thing? So the same way we had different methods of assessing reliability, we're also going to have different ways of assessing construct validity. The first and most obvious way of assessing construct validity is what's known as face validity. This is just how much does it make sense? How much does it feel like what you're measuring measures what you think it's measuring? How much does it just kind of ring true in your mind? So if we ask about feelings of hopelessness or pessimism, we feel like, hey, that should be measuring happiness and that should be measuring pessimism. We ask how sad you are. If we ask how happy you are, those feel right. We can ask about persistent empty feelings, anxiety. These are very accessible phenomenon that we kind of understand. And so we think if I'm asking it, we're probably measuring what we think we are. That is high face validity. But it should be kept in mind that just having high face validity doesn't guarantee that it's valid. Just because we think that it's measuring what we want, just because it feels right, doesn't mean it's true. For instance, there was a long time where people thought, well, how do we measure intelligence? Well, intelligence is how much the brain is working and how sophisticated you are. So it must be that more brain equals more intelligence. And so if you have more brain, then you must need a bigger skull. And that's the logic. So people who have bigger skulls must have more intelligence. It has a very face valid, feels very logical, but we now know that's absolutely not true. Skull size has nothing to do with intelligence. So just because it's face valid, just because it feels right, doesn't mean it is. So we really have to evaluate this face validity. Also, the flip side is true, that just because it doesn't feel right doesn't mean it isn't. There are many measures out there that you read and think, well, that's weird, but it's actually assessing, we found out it's actually assessing what we want it to. For instance, there's the Minnesota Multiphasic Personality Inventory, the MMPI. That's a mouthful, the Minnesota Multiphasic Personality Inventory, which is a personality test that is designed to measure how you respond, not necessarily what are you responding. My favorite example of this is one of the questions is, who do you like more, George Washington or Abraham Lincoln? Who do you identify with more? Oh, what? Abraham Lincoln, George Washington? What does that even mean? And the reason it's asking this, you'd pick one, and it turns out it's a measure of authoritarianism. Which one do you, the one who follows rules or the one who broke away and started a war? Which one do you kind of identify? The kind of go-getter out there or the keep everybody together as a country? That's the kind of what it's trying to assess. It doesn't feel very face valid, but it is measuring this other phenomenon. And some scales are specifically made so that they can disguise the purpose, so that they are not clear what they are measuring. And maybe there's some deception involved in it. And so we want to be low face valid. We don't want our participant to figure out what's going on. So we have to be a little shady and decrease that face validity, even though we're still measuring what we want to measure. There's another aspect of face validity, which is just, are you measuring all the content that's there? Does it capture all the parts of the construct of interest? So for instance, in happiness, are we measuring how happy people are, but are we also measuring the absence of unhappiness? Are we measuring their satisfaction or not? Are we incorporating that in to get a kind of robust measure of happiness and well-being? And this one is a little challenging because it's very subjective. It's usually the experts who have kind of figured out what are the elements of the construct that all need to be put together as the overall content here. And if it's missing kind of aspects of the construct, then it doesn't have the same content that you want it to. It's not measuring all parts of that construct. So you got to become an expert to figure out this content validity, but it is something to keep in mind that just asking one question isn't always going to get at everything. This is why we have those multi-item scales. The next method of assessing construct validity is known as criterion-related validity, or just criterion validity. This is the idea that people who have more of the construct you're measuring should also behave in certain ways, and the people who don't have that construct should behave in different ways. So it's the extent to which a measure can distinguish the participants who should act in line with your construct versus those who don't. Is this measure related to relevant objective outcomes? So for example, we would expect that if we're doing some kind of social anxiety metric, that the people who scored higher on that social anxiety measure should also showcase a behavior of social avoidance. This criteria of, if I'm socially anxious, I'm also a little socially avoidant, should be linked in some way. And if we find they're not, that the social anxiety measurement has absolutely nothing to do with social avoidance, that's going to be low criterion. We also would want to see as an example that SAT scores, these measures of college performance that we think are measures of college performance, well, does higher scores on an SAT actually predict college performance? Do the behavior of doing well at college, is it associated with the SAT scores? And if it's not, as some people are finding, then it has lower criterion validity. And we need some different kind of measure. We know that it's not actually matching our criteria. Now recall that I said that different groups should behave in different ways. So another way we can go about criterion validity is looking at what's known as the known groups paradigm. And this is when, if you absolutely know that two groups should be different, then you want to see that they are scoring different on your measure. So you give them the measure, and if these two differently behaving groups score differently on your measure, that's great. But if you give to two differently behaving groups in some way that's related to your construct and the groups score the same, well, that means your measure probably isn't measuring your construct as well as you want. So we do all this math, we do all these comparisons, we use some correlations between the scores so that we can actually see if there's a relation between the behavior versus the measure that we have, and we work from there. All right, so we just went over some major types of validity with our face validity and criterion. Those are going to be used very heavily. But we also have some other versions. Here we have convergent and discriminant. These are very related to each other. Convergent is when you expect a correlation similar to that criterion, but this is when you're correlating with other measures. So whereas criterion was correlating between your measure and an objective behavior, now we're doing between measures. So for instance, if we have an embarrassability, how much you get embarrassed measure, we would expect that that would correlate with a shyness measure as well, or negatively correlate with a confidence measure. So these are other measures of different constructs, but constructs that we have a theoretical reason for them to be related to our construct. Shyness and confidence have a theoretical relationship to embarrassment that we will understand and expect to see from our measures. Now, this assumes that your shyness and confidence measures are valid and reliable, so you need these other measures you're using to be good measures, and then you can test your convergent validity. The other side of the convergent, if we're looking at positive correlations and negative correlations, is discriminant validity. And this, if you have positive and negative as two options in a correlation, the other option is no correlation, is zero. So discriminant is showing I don't think my measure should be related to another measure in any way. It is a completely different construct, has absolutely nothing to do with another. I don't care what somebody's scoring on the other measure versus mine. They shouldn't be related in any way. So for instance, how much embarrassment you have should not correlate with sense of humor. You can be someone who experiences embarrassment and have a great sense of humor. Or you could be someone who's never embarrassed and have a great sense of humor. Humor has absolutely nothing to do with how embarrassed you are. So with discriminant validity, we expect zero correlation or close to zero. And when I say zero, I don't mean an actual zero. I just mean a weak correlation, closer to zero than it is to 1. So looking at about the -3 to 3, that's usually what we think of as a weak correlation. But again, not negative, because once it becomes a negative correlation, that's showing that there is a relationship between them, that as you score higher on one, you're scoring lower on the other. The constructs are linked in some way, and that's convergent validity, not discriminant validity. In convergent, you're seeing how does it relate. In discriminant, you're saying how is it different, discriminating between them. The last two ways of assessing construct validity are concurrent validity and predictive validity. A concurrent validity is kind of like a criterion validity, except it happens in the same moment. So with the embarrassment example, if a person scores high on an embarrassment scale, we would also expect that at that exact moment, they are also enacting a behavior that is linked to embarrassment. So here, blushing. Again, it's very similar to criterion, but criterion is just saying somebody who is scoring high on my measure should also generally score higher on this other behavior. So the person who generally is socially anxious should score higher, should also showcase more avoidance. But this is a very situational form of validity, that momentary link between the measure and a behavior. Predictive, on the other hand, is looking to the future. That if somebody scores high on your measure, are they likely to do some kind of future criteria behavior? Are they going to act in that way? So embarrassment, if they score high on your embarrassability scale, we would predict that they wouldn't necessarily sign up for a public speaking class. right? And if they scored low on embarrassment, maybe they would be more likely. Now, of course, there's error here, and we can think of examples for all of these. Like somebody who maybe gets embarrassed wants to kind of push themselves out there and do this public speaking class, but that might be a very individual, random error that would hurt the validity. But predictive validity is just saying, is there generally an association between current measure and future behavior? All right, so as a review, we had a lot of different validities here. We had the face, which is, does it seem plausible? Does it feel right? The content, is it capturing all the different aspects of your construct to meet that definition, not just one aspect? The criterion, is it related to objective behaviors? The convergent and divergent, what's the relationship between your measure to others? Is it related or is it unrelated to unrelated constructs? And then the concurrent and predictive, that very similar to our criterion validity, but more about the at one time point versus in the future. All right, so I know those were a lot of different definitions. You definitely want to practice with these. Your book has some really great examples of these different kinds of construct validity to help encase them in your brain and kind of figure them out. And when you are looking at any kind of measure, you should always be thinking about these validity of where is this measuring, or where are ways that this is measuring what I want and what I think it is, and what are ways when it might not quite be getting at it? What are some sources of random error that might be affecting the validity? So reliability, this consistency over time. Our validity is the accuracy of the measurement. We always want to keep both of these things in mind, because even if we are reliable, if we're not valid, we're not a good measure. And if we're not reliable, if our measure is not able to reproduce it, then we're not valid. We need both to make a good measurement scale, which is something we'll talk about in the future. So today, measurement, reliability, construct validity we discussed. So next week, we are going on to our exam one review. We're kind of wrapping up this kind of initiation to research methods. And then after the exam, we're going to go into actually developing surveys, talking about more observational methods, and working from there. All right, have a great time.